Oh,
I'm a little slow today.
no. I didn't know what it was when I was first looking at it because I opened it up like 10 minutes before we got together. Okay. So X bar is, do we know X bar?
X bar is
Is it
the
zero?
sample mean.
X bar is what?
Is it zero?
Why 0?
Because that's the hypothesis, right?
Mm-hmm.
Because aren't we doing the D plus or minus T times, no, because we don't know the sample mean. Yeah, the sample mean difference is 3.3. So we'd be doing plus or minus T times the sample standard deviation over the square root of the, because are we doing the confidence interval for matched pairs? Yeah, paired data.
But
Doesn't that
we're just trying to find the value of the test statistic. I'm so confused. What formula are we using?
I think we're using that same one. So mu. What is mu? Oh, again.
That's the null hypothesis.
Yeah.
Why am I so confused?
Sorry, I'm probably not helping. Okay, a one sample t-test is the t equals x bar minus the mu with the O over S divided by the square root. But the paired sample is t equals d minus O over SD over the square root of n. So d minus the null hypothesis. So d is 2.2. So wouldn't that be the 2.2 minus 0 divided by 3.3 over the square root of 9?
Okay, so where did you find that formula?
In my notes.
Oh, okay. Can I see it so I can write it down?
Can you see?
I think it's in the.
That one? I don't know what I'm showing you because I can't tell. Can you see that? It's the t equals. Can you see it?
Oh yeah, d O over SD over square root of n. Okay, got it. Thank you.
Yeah. So
So d equals the population mean.
the d is the mean of the differences, and the O is the null hypothesis.
And the SD is the same. Okay.
Is the sample standard deviation over the square root of the sample size.
Yeah, that's right.
This is only for a paired t-test, correct?
What?
This is only for the paired t-test, correct?
Pair 2, I think so.
Yeah, okay.
So that would be 2.2 minus 0, right? Divided by 3.3 divided by the square root of 9.
Yeah, I got 2.
Okay.
Hold on. I'm just writing the thing down to make sure I have the right formula.
Yeah, 2.2 divided by 1.1 equals 2. That's what I got also.
Okay.
I also got 2.
Awesome.
How are we supposed to round it to 3 decimal places, though?
I think it says them on a lot of them.
Oh, 5. Just kidding. I was looking at question 6. That made no sense.
Okay.
Jordan, are you good for number 3? Did you get your calculations finished?
I didn't do it, but I understand it.
Okay.
I get it.
Perfect.
Okay. Number 4, the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
Yeah, this is where I get confused because I don't remember how to find p-value. And I don't know if we're supposed to use the app or the SPSS or the.
It's just the applet.
Okay. Oh, okay.
0.
The what?
So we go into the applet and just do the 0.0403?
In the area or as a z-score?
In the area.
In the area.
Okay. So 0.0403.
That gives us
And we're
this.
looking for
Or-
it greater.
What?
We're looking at to be greater than, and so it would be
You just shade
Um,
in
2.051.
2.051. So that's the answer, 2.051.
Yeah.
The p-value is just the z-score.
No, it's not, is it?
The p-value?
The p-value.
Is the p-value the z-score?
No, the p-value is not. The test statistic is the z-score.
Yeah.
Oh, wait, so probability of obtaining a test statistic greater than. So, oh, the test statistic is. So we put that in. Okay, so no, we're putting in.
0.484.
Yep. Wait, what did you get?
I got 0.484.
How did you get that?
So to do the p-value, isn't it x bar minus mu over,
Yeah, it's
what is
484.
that?
Because the test statistic is the z-score, like Heather said, and then you put it in, and then
That's what I did. I'm sharing my screen.
yeah,
Oh, wait, let me.
the p-value is the area.
Wait, so
Wait, what?
where did that number come from?
Yeah, where'd you get that?
So I put in so the test statistic I put in for the z-score. So I put 0.404 into the z-score, and then since it's greater than, I shaded everything to the right
Yeah.
and got the area.
Where'd you get 0.404?
I mean 0.040.
484. Sorry, 4840.
Wait, what?
Okay.
So if you plug in go to the normal probability app,
Mm-hmm.
and if you plug in 0.0403, it will go to the third decimal. Doesn't matter, but plug it in and then shade to the right, and then it will put 0.4840.
So,
When I do 0.0403, I get, and I just shade to the right, I get 2.051. There we go. Sorry, hang on.
Is it 0.040?
0403, I get 1.747. But maybe I'm doing it wrong.
I mean, I got 0.484, but I thought to find the p-value of something. Oh, I guess that's.
Wait, do I put the 0.0403 in the z-score?
Yeah.
Okay, that's where I was wrong. And then it gives us 0.4840. Okay.
Yeah, because Heather was right. So the test statistic is the z-score. And so the probability is the area.
Hold on, wait a second. I'm not sure I'm right because the 0.0403 isn't a test statistic. Rereading the problem, that's the probability of attaining a test statistic greater than Jordan's test statistic. So that's a probability, not a test statistic. Because it can't be that simple, right?
Oh.
I don't know. I mean, that makes sense to me, but at the same time.
So, all right. So the probability of obtaining a test statistic greater than, so we know that we're shading to the right of a test statistic. It's 0.0403. It makes sense.
Okay, hold on. On the okay.
No, I think that's.
Oh, you know what? On the wiki, that's it says to me the same thing.
Yeah, you put the z-score down in the
Yeah.
and then the area is your
Yeah.
p-value. Yeah.
So that's right then.
Awesome. Good job, guys.
Okay, so now we're using SPSS. Use the data
I still don't
file.
SPSS, just so you know.
What?
I still don't have SPSS. I'm sending my laptop in today, but I'm not going to have it back for like 5 more days. Kind of annoying because I can't do any homework either.
Yeah.
Well, that's okay.
So number 4 is 0.484, right?
Yeah. So use the data in Chapter 12, Data A, to answer the next 6 questions. Perform a paired sample test in SPSS. Be sure that the test group does group 1 minus group 2. Use the null hypothesis. Okay.
So we're basically doing the same thing we just did.
Yeah, but now we're doing it in SPSS.
Oh, we'll do it first? Nice. So, when I watched the redheaded kid do it, apparently you try to find the difference first,
Yeah.
and
Yes.
then you use that.
There's a step-by-step on the wiki.
Huh?
There's a step-by-step on the wiki.
Yeah.
Yeah.
It's group 1 minus group 2.
Yeah.
And then you
Gotta
can.
No,
transform,
no,
right?
it's grouped. I think it's group 2 minus.
It depends on what the problem
Well,
is.
it says right there in the
Oh,
problem, it says
yeah. Group 1 minus group 2.
the test does group 1 minus group 2. So if you go up to transform and then do compute variable, then you just hit the group 1 and put it into the numeric expression, then do the minus and then group 2. And you're just doing the difference, right? Does everyone know how to do that?
Yeah.
Yeah. Give me a second. My SBS is loading.
So we're doing group 1 minus group 2, right?
Yeah.
Okay.
Yeah, that's nice that it does it for us.
I'm starting to not hate SPSS so much.
I know, I'm starting to love the SPSS question.
If I can just figure it out and know what the test value is. Like,
So you shade.
but we're using the significance level of 0.10 also.
So actually,
Wait, so what's the test?
so here, can I share my screen real quick? Okay, so I did the group 1, brought it over, minus group 2, but I can't click OK.
You got to type in at the target variable, you need to type in difference.
Yeah, or whatever you want to call it.
Okay, there we go.
Yep. Now it's just
That's what I was missing. I'll just keep sharing my screen though so you can see it, Heather.
Okay, thank you.
So now we go to compare, right? One sample t-test.
is that what we're doing?
How come mine doesn't show up after I did that?
You're on the wrong screen.
Perform a paired sample t-test in SPSS. Okay.
Oh, weird. Okay, so then we go to, what is it?
Compare
Data?
means and one sample t-test, right? So if we've got to do the 90%, don't we?
So wait, where did you go? Just to data again?
I went to, well, I'm not sure if I'm doing it right, but I went to goodness, where was it? What am I doing? Oh, no, mine's frozen. You just keep me out.
Oh, compare means under analyze.
Yes, one sample t-test.
Yeah, and make sure you do the value. Let me make sure, but I'm pretty sure the value is supposed to always be 0.
I recall that from my last class of the test. Value is 0.
Okay.
Yeah.
And then we got to do 90%, right?
So just to make sure, so with only pair intervals, when only we're comparing intervals, is that when it's 0?
Yeah.
And then when we're just doing a regular t-test, or regular t comparison, we use the actual null mean?
Yes.
Okay. All right.
But
And we make sure that we highlight the difference, right? Not group 1 or group 2. That's what we bring over.
And when you go up to options, we do, is it 90% because it's an alpha level of 10%? So don't we do 90% instead of 95 for the level of significance?
It depends on what the question is asking.
It says the alpha is 0.10.
So yeah.
So it's a 10% significance or a 0.10 significance level. That's in the
Oh, that doesn't. That no. You don't change. That's for the confidence level, not the level of significance. The confidence interval.
Oh yeah.
oh.
Okay.
The level of significance only affects whether or not we fail to reject or reject the null.
Yeah, but it's up in the confidence. Oh, that's the confidence interval percentage. Okay.
Yes.
So that's not the level of significance?
No.
Oh, okay, so we keep that at 95%?
Yes. Unless it's specific, like it'll ask you specifically what confidence interval it wants in later questions, and then you can.
Like if it wants the 90 or.
And that's not what it was doing there?
No.
Oh, okay. So what does that mean when it says at the 10%?
That means that if the p-value is greater than the 0.10, then we fail to reject the null. If it's less than, then we reject the null.
Okay. So the level of significance is different than the confidence interval. I need to write that down.
So then the test statistic is 0.407.
Mm-hmm.
That's what t is.
That's what I have right here.
And
0.407.
And then so the p-value will be that two-tailed test, and then is it divided by 2? It's divided by 2. Is it? Or no, it's not divided by 2. Sorry.
It's a one-side, or it's a two-sided test, right?
Yeah.
Mm-hmm.
So
0.689.
yeah.
So
P-value.
if it's two-tailed, you don't divide it by 2.
Correct.
If it's the equal sign, then you divide it by 2.
It's never going to be equal sign because that equals will be the null hypothesis. The alternative will always be does not equal, greater than, or less than.
But you mean the equal sign with the slash through it, right?
Yeah.
Yeah, that means it's two-sided. And if it's got the greater than or less than, then it'll be one-sided. But since it has the equals with the slash through it, then that's our alternative. So yeah, it's two-sided.
So I'm just so confused when we divide it by 2. I don't know why that is such a struggle for me, but it is.
Divide it by 2 whenever it's greater than or less than.
Yeah, if it's equal to, then it's two-sided.
But oh, okay. Okay.
It automatically calculates it as a two-sided. So you just have to fix it if it's only one-sided.
So this is how you would see it on your p-value.
Oh.
On the normal probability app, because it's like this.
Uh-huh.
There's two sides shaded,
Okay.
and if it was like asking for greater than, then it would look like this, and this is what it would be. And if it was asking for less than, this is what it would be.
Okay. That makes sense. I watched a video on YouTube about that. Okay. Let's see. 0.689 is
Are we on number 5?
yes.
This is 0.407, right?
Oh yeah.
Test
And then number 6 is 0.689. Right?
Yeah.
So if the
And
level
then-
is 0.1, then 0.689 is greater than, so we would fail to reject.
Yeah.
I finally have that straight in my head. I struggled with that so much last time.
I know I always have, okay, with P is null, or P is low, reject the null. So,
Yeah.
Yeah, I always have to say that to myself too.
me too. Okay, so those are alternative.
Okay, and so Sarah, the next question, question 8, this is when we would divide it by 2.
Oh, okay. Got it. So suppose your alternative hypothesis instead blah, blah, blah. What is correct decision based on this evidence? Ugh, these are always the worst questions.
Wait a minute, but the level of significance is 0.10. So
Correct.
it's still, we'd still reject it, wouldn't we?
Yeah.
Okay.
So if we reject the null, no, we would fail to reject it.
Yeah, because it's still greater than the 0.10.
Right. So then would it be we have insufficient evidence that the mean of the difference is greater than 0?
Yeah.
Oh, wait a minute, but did we take into consideration that there's a 0 between the two, between the lower and the upper?
What?
Because the lower is
Huh?
negative 1.28 and the upper is 100.
Yeah.
So if there's a
So-
0 in between, we reject it either way anyway, don't we?
I don't understand what you're asking.
So if there's, yeah, so right here, is it that way or is it the other way? Do we only? I know what you're saying, Tara. So like this, in order for us to reject the null, this would have to be below 0.
Or the lower
Right.
would have to be above 0. Yeah. We
Exactly.
only reject the null
In
if they're
order-
both on one side.
In order for us to reject the null, it just has to be less than the level of significance. That's all.
Not on a two-sided, not on a double, or what's it called? The
A pair comparison.
pair, yeah.
Pairable.
Because if the mean, if 0 is in between the upper and the lower,
The
Then
upper and lower of what?
The
um,
upper and lower of the upper bound and lower bound of the
Of the confidence interval?
yeah. There's something about that in the video.
mhm,
This is
then we reject it because the 0 is in, if the median is,
Before we would use software, either Excel or SPSS.
Oh, okay, I see where it says that. But isn't it the same answer though?
I think we reject it either way, don't we? Because the 0 is in the middle and because the p value is. I'm trying to see if it's in the book anywhere. Because we're starting with a null hypothesis of 0, right?
Yeah, and so
So
if
if
it
0 is
is,
in between the data, then regardless of the level of significance, we still would reject it, wouldn't we?
because it's greater than 0, because the higher compound is greater than 0.
And the lower is less than.
Yeah.
Wouldn't we reject the, no, we would fail to, well, wait, so would we reject the null hypothesis? No, we'd fail to reject it because it's still,
That's confusing.
yeah.
Because it is above the level of significance, or below the level of significance, or above the level of significance.
But if we cut that in half, then what happens?
It's still above the
Yeah,
level.
it's still above.
Because 0.689 divided by 2 is 0.3445. So you still get, it's still above 0.1.
Yeah, but I'm just wondering why there was.
I am so lost in what you guys are saying right now, by the way. I don't know what's going on.
I don't know that it mentioned it in the book though, did it?
There's, the only thing it says about that is like, it says it's like a relationship to one sample t-test.
Mm-hmm.
And it says like, the null hypothesis is that the true mean difference is 0. The alternative hypothesis is that there's a decrease in weights. In other words, the true mean difference is less than 0. But I don't think, I think it's the same thing. As long as it's above the level of significance, then that's what determines whether or not we fail to reject or reject the null.
Yeah.
Watch the videos, but that makes sense to me.
Yeah, I just can't remember why.
Oh, what about...
So it's either.
So I'm reading... Can you guys see my screen?
Mm-hmm.
I just don't know. Maybe this will be helpful here.
Yeah, that's
'cause-
what I was looking at, but I don't think it makes a difference. At least not in this problem. I could be wrong.
Can't.
No, I guess if we get it wrong, we just go back and look at it again. So, so we're saying that we have,
That's above. So
so for number 8, we're saying we have insufficient evidence that the mean of the difference is greater than 0.
That's what I have.
Now, this year, one-sided test.
So we can try that.
Yeah.
it makes sense. I'll probably go back and look at how White did that.
Mm-hmm. Okay. Well, if we get it wrong, we know to come back and look at it, right?
Yeah, we'll know which one it is. Oh,
So
great.
we're putting, I put B, right?
Yeah.
Mm-hmm. Okay, so I already have it pulled up in SPSS. I already did the difference thing.
Cool.
So the question is, which is greater, N or DF? So DF is 21. Where does it? And N is 22. So N is greater.
Yeah.
D is always going to be lower because isn't it just N minus 1?
Yes, it is actually.
Yeah, DF is the degrees of freedom.
Yeah.
Okay, so the p-value is 0.001, but oh yeah, because we still don't divide that by 2, right?
Right.
Okay, 0.0011, and what's our alpha here? 0.01. So it's lower, so we reject the null, right?
Mm-hmm.
Okay, so you decide to try an alternative hypothesis. This time you use. Okay, so now we're gonna divide by 2.
Mm-hmm.
So it would decrease.
It would decrease, yeah, because you're dividing it. So what decision do you make? Now
We still reject
We'll reject the null, don't we?
yeah, because it'll be even smaller. Okay, so based on your response from the previous question, what conclusion would you make? So because we're rejecting the null, that would mean we have insufficient evidence, correct?
We have insufficient evidence that there is no mean difference between the two groups. Is that right?
Wait, what was the p-value? Sorry.
I thought we rejected the null.
We did reject the null.
Yeah.
So by rejecting the null, we're saying that we have sufficient evidence that there is a mean difference between the two groups.
That there is a mean difference?
Yeah, because the null is that there isn't a difference, and the alternative is that there is. So if we reject the null, we're saying that there is evidence that there's a difference.
Right, that's what I thought you said it was A. I was thinking you said that there's no mean difference between the two groups.
Oh yeah, no, I'm saying C.
Okay. As we have seen in the p-value depends on the alternative hypothesis in general, which alternative hypothesis will give the smallest p-value.
Well, not that it's not equal.
Yeah.
Would it be greater than or less than? Or would it be not enough information because it could be either?
Yeah, because I thought it'd be either. I thought either way with those you would divide it by 2.
Yeah, because the greater or less than would divide it in half, where the two-sided would double it, so
That's what I would think.
So C?
be not enough information too.
Wait, can you catch me up real quick? Sorry.
Yeah.
Yeah, sure. Where are you, Jordan?
10.
10?
Yeah.
Okay.
0.001.
Can you see my screen?
What is it?
0.001 is the p-value.
And then
You can see my screen, right?
no, I'm on the different.
Oh, gotcha. So 11's reject the null. Then decrease. And then reject the null again. And then C. And C again.
We think 15 is C.
Right. Okay, so determine the 95% confidence interval for the mean difference between the two groups.
So you should have, were you already set to 95, Sarah?
Yeah.
Okay, cool. Well, then we have the confidence interval.
So, is it asking for the lower or the upper?
It's asking for the point estimate for this 95% confidence interval.
Oh,
I don't remember what that means.
I don't even.
What is the point estimate again?
I
Ah,
don't remember.
Is that area?
Let me try and look it up.
Right here.
What? There's no point estimate. I don't even see point estimate in our.
it's not in this one. It's a review question.
It's a what?
It's
Oh,
a
it's a
review.
review
mean.
question. Oh shoot!
So
I don't remember how to do it.
I'm pretty sure it's the mean. So
The
it's
confidence
X bar. Is that
Okay, so what is it? So does it have an S on there for you, like a little 8S thing?
On SPSS?
Yeah.
You can see my screen, right?
Yeah, I'm looking. I guess not.
I don't see anything.
Is it just the T value? Because it says that
so it says here that the sample mean is the point estimate.
so that means that X bar is the point estimate.
Exactly.
Okay.
So this is where we should get it.
So wait, where do we find X bar?
It's just the mean.
Sample mean, right?
Yeah. Which
Where
would
do we find the sample?
11.954.
Where'd you find that?
11 point.
Oh, okay. 11.99 or 954. Got it. Wait, it shouldn't be 11.955.
Yeah, if we're rounding up.
Yeah.
And then what is the margin of error? That should be on the SPSS as well.
That's the standard deviation, isn't it?
Standard error of the mean, is that the margin of error?
The margin of error, isn't that the
This right here, right?
I thought that was something we had to solve for, but maybe I'm wrong.
yeah, I thought it was the where did I wrote it down somewhere. Oh, it's T multiplied by the standard deviation divided by the third of the sample size.
So can you repeat that one more time for me, Tara?
It's the T with the little asterisk next to it.
Uh-huh.
Then S divided by the square root of n in parentheses. So I'm assuming we multiply the T by the S divided by square root of n. So if n is 22, right?
Mm-hmm. It's 22. T is 3.737.
It's what?
T is 3.737.
Times, and then the standard deviation is what? Oh,
15.00310.
divided by the square root. Okay, I get 11.9534.
Oh, let me put it in. Darn, I don't like doing these ones because it ruins the way I put it in the calculator.
Except that the point of estimate is 11.955. the margin of error would be 11.9. Is that right?
So for the margin of error, so t, you put in order to get t, you put it in the probability app, right?
Yeah. Oh, wait, we did? Oh, is that what we do, or is it the other app?
Uh,
Oh wait, are you guys already on the next one?
no, we're still on 17.
Oh, okay. I was like, oh,
So in order to get the margin of, because we're looking for the margin of error, right?
Mm-hmm.
Okay,
Yeah.
we said it's t times the standard deviation sample, and then over.
in the square root of it.
Sample
Yeah.
size.
I got
Right.
11.953.
That's what I got too.
Let me see. So you did 1.645 times. What's the standard sample?
1.645. Where'd you get 1.645?
We did the t-score.
Yeah.
Which
So
is
the,
The
oh,
3.73. So
7
okay.
yeah.
multiplied by the 1.9545 over.
I just found how to calculate the margin of error for a sample proportion for dummies.
Oh, cool.
Where is it?
I googled and it's how to calculate the margin of error for a sample proportion. So let me look through this.
What's that?
I'm looking through it. Hold on.
The last two are super easy though.
D values of like 1.96.
That's the. Yeah. Well, that's the confidence interval. Or the. Yeah, but
What did
don't.
you put for the? What'd you put for the standard deviation sample?
15.00310.
Wait a second. Whoa, hold on. There is a way simpler way to do this. I just remembered. I will be right back. I'm gonna grab my notes from my last class because it's like upper bound minus lower bound something. I'll go get it. Hold on.
Okay.
So the sample is 22, right?
Yeah. No, N is 22.
Yeah.
Oh yeah. Yeah. Sorry, you're right.
Then is 18 5.303.
Yeah.
19 is 18.607.
Oh wait. What'd you get for 18? 5.03. 5.303.
303. Yeah.
Okay. Yeah. Me too.
18.607.
Yep. That's what I got.
Well, I wrote down the margin of error formula. That's what I wrote down in my notes from watching the video. So I don't know if it's right, but that was I just, when it was saying the different steps, and then I just wrote that down.
Yeah. Well, I think that's what I remember doing previously.
Yeah, that's what I've got. So I don't know.
Yeah.
But this is
Kind of want to submit it.
And my chair is so squeaky.
I know. No. I know, I forgot. Sorry.
It's his day off.
It's his day.
What do you do?
Okay, so
He goes, it's his day off. It's totally not his day off though, because he started MCAT prep, and so we just bought the Altius program, so he has
Oh gosh.
7 months worth of studying, 8 hours a day.
okay,
Not more.
so I got it. So the margin of error is the upper bound minus the lower bound divided by 2.
Upper bound minus the lower bound divided by 2. I'll see if I get the same answer. So upper bound 18.6065. 5.3025 divided by 2. I got 6.625, which is not what I got doing the other.
Yeah, me neither.
So I have my notes from the class for this lesson 12, for the two samples paired. And I have the confidence interval is D bar plus or minus the margin of error. We find the margin of error by doing the upper bound minus the lower bound divided by 2.
Well, I mean, we get to take it twice, so we can try both formulas.
Mm-hmm.
As always.
Which one do you want to try, Jordan?
Let's try the standard deviation. Well, the one that we did. What's it? What's the answer again?
18. Oh, sorry, that was the last one. I got 11.953.
That's just so close to the mean.
Mm-hmm. That's what I was looking at too. It's almost the same.
I almost think it's this thing right here.
We'll try it. Yeah.
The 6.652?
No, the 3.198.
Oh, okay. Yeah, try
I
that.
Which one?
remember. I remember him like pointing to this. Can't remember why. No, it's not this because I did the same thing on what's it called? The last test.
Well,
no,
try doing the upper minus the lower divided by 2.
Yeah, I did that in my calculator and I got 6.625 or 6.652. I always switch my numbers up.
No, I'm so dyslexic.
That's what I got. Too.
Okay.
Okay.
Make sure I got everything. Okay.
Dun, 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 dun. Moment of truth.
That's a good sign. We missed one.
We did?
6.652 is right.
Awesome.
Oh, nice.
That's that's probably what it was on the last one. So the margin of error is upper bound and lower bound divided by 2.
Upper bound minus lower bound divided by 2. Can you guys tell me what 18, 19 are? Sorry, I was getting my notes when you went over that.
Oh,
Yeah,
yeah.
it's 5.303 is the lower.
Okay.
And 18.607 is the upper.
Awesome. And did we? Yeah.
07, you said?
607.
Okay, so it's 5.303 and 18.607.
Yeah.
Okay, cool. And we got everything else right?
We missed one, but knowing my history, it's probably one that we got right.
Number 4.
Oh,
Which one did we get wrong?
0.484.
Is the p-value one.
Oh,
Okay, so it wasn't the.
What number is that?
That was number 4. That's the other one we were confused on because.
Yeah.
Yeah.
Dang it. That's in the other SPSS thing.
I think I'm.
so in my notes from last time for number 4, I have the answer is 2.
For number 4?
Yeah. I might have
Then
gotten
number 3 is 4.
Hold on. No, that's probably not right. Never mind.
Number 3's answer is 2.
Yeah.
Yeah, number 4.
I don't even think we thought we were confused about that.
That's the one where we were doing it in the applet, but we didn't think we were supposed to.
Yeah.
Oh, right. Yep. Never mind.
Probability.
Greater than Jordan.
What's the probability to
Did we
determine.
get number 5 correct?
Yeah. Yeah, so we still base off the, what's it called?
Oh, I don't know.
Wait, but Jordan, what was your answer for number 4? Did you get 0.484?
Yeah, he
Yeah.
did.
Okay, just making sure before we can figure.
Maybe we should try a formula. Z equals x bar minus mu over standard deviation over the square root of n.
Sounds good. Is that the is that how you get the?
That's the p-value method for the test.
Yeah, I agree.
Say that one more time.
So it's z equals x bar minus mu divided by standard deviation over the square root of n.
Okay. I think, isn't the problem with that though that we don't have X bar or mu?
But we have the test statistics, so we could use a little algebra.
So it would be
So it would be 0.0403 equals x bar minus, what's mu?
We don't have mu either.
it would be the null hypothesis.
Oh, you know what? Isn't
Minus 0. Oh, but the standard deviation is not known.
Isn't it 3.3?
Yeah. Divided by 3.3 over the square root of 9. Let's try that.
So it would be. Was it the same exact thing? Was
But
it?
that's the formula. Yeah, that's the formula we used for number 3 because that was.
Yeah,
No, but we
it's two-
didn't use algebra for it
Oh, that's true.
So
because we.
2.2 subtract.
Am I still sharing my screen? Because now we have it like this,
Hold on, Jordan.
right?
What?
But does anyone? Am I still sharing my screen? Or is my screen even on?
Yeah, yours.
Oh, I need to stop sharing the. So now we would have it like that, right? So that's different than the formula we used.
But don't we have X bar?
Yeah, X bar is the this right here is 2.2, wouldn't it be?
Yeah.
Okay, well then we're missing, because see how it says that the standard deviation is not known? It says
Yeah,
that in
so
the
you
problem.
use the sample standard, which would be 3.3.
Yeah.
Okay, maybe I'm wrong.
2.2.
In which case, I don't know what to do.
But you're right. We're using the probability. Well, that's the probability. So
right. So that's that's kind of what I was saying before. The 0.0403 isn't the test statistic. It's the probability.
wouldn't that make it the 1.747? Well, no,
Sure.
that's the z-score.
Actually, it might be. We can try it.
Yeah.
What is it? I'll try it.
Well, if we use the probability of the 0.0403, but wait, what? But that gives us a z-score of 1.747. But where is his test in the? Because it has to be greater than that, right? So where are his parameters in? Do you know what I'm saying? the probability of obtaining a test statistic greater than his is the point. Oh, okay. No, yeah. That sounds like it would be right. So wouldn't it be the 1.474?
1.747.
Yeah.
Let's try it. Let's just try it and see.
I'll try it. I'll submit.
Okay.
Me too. Oh well.
Oh, are you submitting? Double. Okay.
I still got -1. Yeah, it's still wrong. This might be the first one we don't get 100 on.
I know. That's not like us.
I refuse it.
What?
I'm rejecting this problem.
That's right. I reject the null that this problem is solvable.
I hate that it doesn't talk about this at all in the wiki.
But what's Jordan's test statistic? So 2.2, right? So there's a. So we're looking for the probability of getting a test statistic greater than 2.2 is 0.40 or 0.043. Do we put in the 2.2 to the probability applet? No, we can't, because we can't use the normal probability because it's not a, isn't the sample size too small? Because if I do a 2.2 as a z-score, that gives us an area of.
The z-score can be greater than 1, but not the area.
Yeah. So if we did a z-score of 2.2, then that gives us an area of 0.0139.
0.0139.
Mm-hmm. Or 0.014 if we rounded.
Do you want to try that one?
Yeah, let me try that.
Sounds good.
What is it? 0.014?
Yeah, let me try that and I'll see if it takes it.
Wait a second. Oh my gosh, I just had a brain.
Nope, that's not it either.
Okay, wait, I have an idea.
Okay.
So in my notes for this question, I wrote multiply it by 2 because it's a two-tailed test of the alternative hypothesis. So this is changing the hypothesis, correct? The original one does not equal 0. And so if the probability couldn't we divide that by 2, because the probability of obtaining a test statistic greater than is the p-value for an alternative hypothesis, right?
So what you're saying is the p-value is 0.403, but we're trying to find if it's greater, and so we divide it by 2?
Or mine says multiply it by 2. I don't really know why you would do that, but I might have written it down
The
there.
notes led us to the right place for the confidence interval or whatever it was.
Yeah. Let's go with it.
So 0.0806.
Try it.
Okay.
0.006. So you
0.01. I'm going to try it and just see if that works. And after this, we're kind of out of tries. So.
Well, if it's not that, then we may just have
Got our first 95.
ruined our.
That's right. That's right. That is right. It's 0.081.
Oh, okay. So tell me.
0.081.
Yeah.
0.081?
Yeah, that's the right answer. So what I did was I multiplied it by 2. I multiplied the probability by 2.
Cool.
Never would have thought.
Okay, she's our girl.
Neither would I. I'm pretty sure that one of the TAs told me that. So.
Wow. Why is that not in regular reading and stuff?
Yeah, I would never have come to that conclusion.
Did you guys do your midway feedback?
Yeah.
Yeah, and I wrote one more time about how terrible the textbook is.
I did the same thing. I did not rank it high.
Oh, wasn't that for last week when we did that?
Yeah.
Mm. Cool. Good job, guys.
Yay! Thanks, Heather.
No problem. Thanks, Brother Saunders.
Thanks, Brother Saunders.
Okay, I'm gonna go eat some lunch. I'm so hungry.
Well, enjoy.
Good job, guys.
Yeah, good job, y'all.
Cool.
Go
See you
click
on Wednesday.
I have lesson 13 too, so I'll keep the notes handy for Wednesday.
Sweet.
Awesome.
All right.
Thanks, y'all.
Bye.
Have a good
Bye, guys.
Bye.
Bye, guys.